All right, I'm back. So walking happens, excuse me, the T1 of walking actually happens at 8 seconds, and the T2 of walking happens at 48 seconds. Because the walking starts at 8 seconds, and then he's 40 more seconds back, so that's 8 plus 40 is 48. And then x sub 1 equals 50, and x sub 2 means he's gone all the way back, so he's at 0. So when we do our little average velocity here, x sub 2 is 0 minus 50, and t sub 2 is 48 minus 8. So we end up getting negative 50 over 40, which reduces to negative 1.25 meters per second. Please notice how it's negative because he's walking left. And then part C, they want the total average velocity. So I'm going to write a V with AVG beside it, which stands for average. Okay, so what we have to notice about here is that x sub 1 is 0 and x sub 2 is 0, because x sub 1 means he starts there, and for the total thing, like here's his starting point and the whole thing, so that's there and back. So x sub 2 is also 0 because he was going back to the beginning spot. T1 is 8 seconds, and T2, remember we talked about it takes him 8 seconds and 40 seconds, so that's 48 seconds altogether. Oh, excuse me, T1 is 0 seconds, for the start to the stop. So this time we're going to do our slope again. So we'll do 0 minus 0 over 48 minus 0, which we should all know reduces to 0 meters per second. And that's kind of weird, but his average velocity, because velocity deals with distance, ends up being nothing because, well, he wasn't displaced at all from the beginning to the end of the total trip. Okay. And oh, there's a nice little picture. I said I was going to draw you a picture, but there was a nice little one I forgot about. All right, let's keep having some more fun. We can also analyze various types of graphic representations of particle motions. So this time we're going to look at like graphical motion, okay? Here are some key issues with the graph that is shown to the left. Number one, if we take a look at it, obviously we have somebody starting here at 1 meter, and that's time equals 0. We can see some traveling and stuff, but the problem with just having a graph of it, it's very unclear what the speed is. Okay, and it's also very unclear on direction. But if you look at these, it makes it a lot easier if you were to make it like in an XY chart. And maybe you're smart enough you can pick that up from all of that, but take a look how a position time graph really helps us kind of like look at it and examine it. So we can see at time 0, here's time 0. I know it's so weird. You're used to seeing this as your x-axis, but we would need to think about x as your position. So this is time position. So at 0 seconds, we can see, oh, it is at 1 meter. And then at 1 second, we can say, oh, there it is at 3. And then at 2 seconds, we can say, oh, there it is at 4. So we can really see that it's going faster, then slowing down a little bit. And then at 3 seconds, it's back at 2 meters. So it's really a nice visual here. And there's a lot that goes on with slopes. For example, we can look at slope from different points. Okay. Let me take a look at my answer key before I kind of keep going here. It's going to be here. Okay. So in between any 2 times, we could figure out what the average velocity is. So I want you to look at these 2 times between 0 and 3 seconds. So the average velocity between 0 and 3 seconds is just the slope of the line. Okay. So for example, let's say I wanted you to find on this graph, I want you to find the velocity that's average between 0 and 3 seconds. Well, it's really just the slope. So we find the difference in the y values, which happen to be our position. So the only difference is 2 minus 1 over the difference in the x direction. So that's 3 minus 0. So we do 2 minus 1 is 1 over 3. So you can see that the average velocity just between 0 seconds and 3 seconds is 1/3 meter per second. Or if we wanted to make it a decimal, 0.3 repeating meters per second. So it's kind of nice how that ends up working. Okay. This representation allows us to think of average velocity as slope, and that's actually exactly what I just told you. So let's write this down. Average velocity is slope. We just have to make sure we do it between 2 points, any 2 points in time. Remember, we talked about in like 9th grade, anything that goes up is positive, anything that goes down is negative. So if I asked you to find, let's do this one. Let's find the average velocity between 2 and 3 seconds. Okay, so what we'll do is we'll find our positions. So we're going to have to do delta x over delta t. Okay, so vertically, this changes by, let's see, it was at 4, and now it's at 2, so it goes from 4 to 2. So we're going to do 4 minus 2. Or I guess we should do the second point minus the first. So we'll do, maybe it'd be helpful even if I wrote the points for you. Like, for example, this point is at 3, 2, and this point is at 2, 4. So if we wanted to, we could really just do 2 minus 4 on the top, 3 minus 2 on the bottom, to get negative 2 over 1 to get a slope of negative 2 meters per second. Now remember, that's just for the average velocity between 2 and 3 seconds. But that is all there is to the first lesson. Am I recording?